You know that feeling when you're trying to figure out, like, the real deal with new tech or maybe the greenest choice for everyday things like your clothes?
Oh, absolutely.
It can feel like you're just swimming in information sometimes.
Yeah, totally overwhelming.
Okay, so let's try and unpack this. This deep dive is really for you, the learner. If you want to get a solid handle on a topic, quickly, but without feeling like you've just signed up for a whole university course.
Exactly. We've all been there, right? Wading through endless articles. Today, we're going to try and cut through that noise and look at something genuinely revolutionary. Next Generation Textiles. NGTs, for short.
That's right. And we've got a really great resource to guide us. It's a review article from the Journal of Open Innovation. Technology, market, and complexity. Think of it as like your shortcut. It brings together all the key info from tiny nano innovations right up to the big picture, like how sustainable our fabrics could actually become.
Yeah, this article does a great job mapping out the NGT world. It shows how advancements like nanotechnology and 3D printing are changing what fabrics can do.
And it covers recycling too, right? And the environmental side.
Yes, absolutely. Those crucial elements are in there. Recycling, sustainability, the whole environmental impact piece.
Okay, so our mission for this deep dive is pretty straightforward.
Yeah.
We want to pull out the most important nuggets of knowledge about NGTs for you.
Yeah, the key stuff.
We're talking surprising facts, the really exciting progress being made, and, how all this points towards a future where what we wear isn't just clothes.
Makes it smarter, more functional.
And significantly better for the planet, hopefully. So let's dive in. Where do we start?
Well, let's begin with the basics.
Yeah.
What exactly are next generation textiles? Because these aren't your grandma's fabrics,
Yeah, definitely not.
NGTs represent a real paradigm shift in the textile industry. They're not just tiny improvements, they're a fundamentally new way of thinking, incorporating the latest in materials, science, technology, and, well, what fabrics can actually do.
That makes sense, because for centuries, textiles were pretty much about, basic protection, keeping us warm, dry.
Maybe looking presentable eventually.
Exactly. But now, NGTs are designed for so much more. They're built to meet today's demands. And sustainability is huge, obviously.
Huge, yeah.
But also, much better performance, built-in smarts, and just being incredibly versatile.
And it's becoming mainstream thinking, too. The European Union is really pushing for all textiles to become sustainable. That tells you how important this is.
So what makes them different? What are these key characteristics?
Well, it's fascinating because NGTs really redefine what fabric is. We're talking materials that could have, say, built-in sensors monitoring your health.
Wow.
Or inherent abilities like fighting off bacteria. They might react to their surroundings, change color or temperature.
Responsive materials.
Exactly. Using components made sustainably, adding functional coatings, it goes way beyond just thread. Researchers like Castano and Flatow pointed this out years ago, and it's really coming to fruition now.
It's amazing how far we've come. If you think about the history of textiles, it's such a long story.
It's incredibly long, thousands of years. You start with ancient civilizations giving us linen, cotton, silk, essential materials, really part of their culture and economy.
Then the Middle Ages, lots of wool.
Right. And then the Renaissance, you get mechanized looms starting to appear, kicking off industrial production.
And the 19th century, that felt like a massive leap, didn't it? Synthetic dyes, the sewing machine.
Completely changed things. Then the 20th century brought in explosions of synthetic fibers like nylon and polyester, technical textiles for specific jobs, even digital printing onto fabrics.
Which brings us pretty much up to now, the 21st century. And the focus seems to have shifted again.
It really has. Now it's about embedding electronics, smart textiles, and using nanotechnology, working at that incredibly tiny scale.
And sustainability is right up there.
Yeah.
Absolutely. It's a major driver now. Textiles have always adapted to our needs in new tech, but the current focus feels different.
But it's also fair to say the old ways, the traditional textile industry, it has some serious downsides, doesn't it? Especially now.
That's a really critical point. Conventional textiles, well, they have a pretty heavy environmental footprint.
Yeah.
You've got wasteful production, reliance on scarce resources like water, often limited functionality, and just not being very sustainable overall.
What's the chemicals involved?
Tons of chemicals.
Yeah.
And then there are the concerns about worker conditions and whether consumers even know about these issues. It all highlights why this NGT approach, innovative, more eco-conscious, is so vital.
Okay, so NGTs are trying to solve a lot of these big problems. Let's get into the specifics, the key aspects that make them revolutionary. Sustainability seems like the obvious place to start.
It really is front and center. Sustainability is a core principle for NGTs. The big push is towards using sustainable materials, renewable energy in manufacturing, and responsible production processes to minimize that environmental hit.
And are there good examples of this actually happening, not just theory?
Oh, definitely. Some really cool examples like researchers El Nagar and their team, they developed a simple cotton swab using dye from red cabbage. Totally natural. They can test the pH of sweat for health monitoring.
From cabbage. That's brilliant.
Isn't it? Then you have work by Yen and others looking at textiles that can convert our body's energy movement, heat, into electrical signals. Think about powering wearables without batteries.
So my t-shirt could charge my watch.
Potentially. Maybe not charge it fully yet, but power sensors, yeah. And Veer Muthu's team made wearable electronics inspired by muscle fiber's strong, flexible, eco-friendly manufacturing.
That's amazing.
And even things like UV protective coatings being developed by Adia's group for sustainable textiles, protecting you and the planet.
So, better for the environment, check. But NGTs are also about boosting performance, right? That's functionalization.
Precisely. Functionalization is about using advanced tech to give textiles specific abilities they wouldn't normally have, like water resistance, killing bacteria, resisting flames, or even regulating temperature.
How do they do that? Additives? Coatings?
Both, and also incorporating nanomaterials directly into the fibers. There are various methods.
Can you give us some examples of that in action?
Sure. Cortnell's team created an eco-friendly wound dressing using cotton and recycled plastic blends, but they added natural antimicrobial agents. Really important with antibiotic resistance being such a problem.
Good point.
Zhao and colleagues made a sensor from nylon thread and carbon nanotubes. It's durable, recyclable, and very good at detecting force, like for smart clothing or robotics.
Carbon nanotubes and thread.
Okay. And Jagdish Varan's group developed a coating using iron titanate and carbon nanotubes that blocks both microwaves and UV rays, again with a focus on being eco-friendly.
It's like fabrics are getting superpowers. And it seems to go further, actually embedding smart features right into the clothes.
It does. That's where the Internet of Things, IoT, comes in. Making textiles perceptive, reactive, interactive. These smart textiles are key for wearable tech, health monitoring clothes, even smart home fabrics.
How does that work practically? Like, what can they do?
Well, Wang and Facchetti, for instance, worked on making parts of textiles conductive, basically creating materials that can store or even generate small amounts of power. That helps reduce the energy needed for our wearables.
Right, like we were saying about powering sensors.
Yeah, exactly. And Capineri looked at a pressure sensor in a running shoe linked to a smartwatch.
Yeah.
Tracks your run, obviously. But the interesting bit is the potential to use similar tech to optimize resources elsewhere, like smart heating in buildings based on where people actually are.
So my clothes could talk to the building's thermostat.
That's the kind of thinking, yeah. It's about integration. Our clothes becoming part of our digital lives. And the way they're made is changing too, isn't it? These advanced manufacturing techniques.
Absolutely. Things like 3D printing, building layer by layer biofabrication, which is basically growing materials, and digital textile printing. They're transforming the industry.
How so? More flexibility.
Huge flexibility in design, much easier customization, more precision.
What are some cool examples of these techniques in textiles?
Well, Wu and colleagues figured out how to apply metal coatings to fabrics that stay soft, stretchy, and conductive.
Oh, wow.
Their team also developed nanofiber yarns, incredibly fine threads that mimic natural body tissues. Huge potential for better, more sustainable surgical materials.
It sounds like these NGTs often do more than one thing at once. Multifunctionality, is that the term?
Exactly that. Instead of needing different layers or treatments, you get multiple properties combined in one single material.
Can you give some examples of these multi-talented fabrics?
Sure. Gao's team made a cotton non-woven fabric that wasn't just waterproof and self-cleaning, but it also blocked electromagnetic interference and stopped microbes growing. Think less energy and chemicals for cleaning.
That's impressive.
El Halawani's group developed smart cotton with both antimicrobial action and UV protection using special nanocomposites.
Okay.
And Ghosh and colleagues created this super light, water-resistant fabric from merino wool and nylon that could block electronic signals, conduct electricity, and transfer heat. Imagine one garment doing that. Think of the energy savings.
This is all genuinely fascinating stuff. Okay, let's dig into the how. The specific techniques used to make these NGTs, nanotechnology seems like a really big one.
It's huge. Using nanofibers, nanoparticles, nanocoatings,
Yeah.
it's a key way to boost properties like strength, durability, water repellency, antimicrobial effects, you name it.
How does that work in practice? What are they doing?
Well, Bagherzadeh and their team used a technique called electrospinning. They basically dissolve a polymer and use an electric field to draw out incredibly fine fibers, creating these nanofiber mats.
Okay.
And they found these mats actually outperformed Gore-Tex in being windproof and water repellent.
Better than Gore-Tex. Wow.
Yeah. Sun's team also used electrospinning for a PVA nanofiber fabric that's breathable and flexible. And researchers like Libertino are even developing wearable sensing nanoparticles. Embedded in fabrics, they could potentially change color to show different conditions.
Color-changing clothes. That sounds like pure sci-fi.
Yeah.
But are there downsides to using nano in textiles?
There are challenges, definitely. A lot of these methods use solvents that can be pretty toxic. And some of the nanomembranes aren't biodegradable, which raises sustainability questions long term. But researchers are actively working on greener polymers and solvents to tackle this.
Okay, good to know. Another technique we mentioned was 3D printing. It's not just for plastic models anymore, is it?
Not at all. Additive manufacturing 3D printing lets you create fabrics with really complex, customized designs. Plus, it minimizes waste because you only use the material you need. And it can speed up prototyping.
Can you give some specific textile examples?
Sure. Korger and colleagues used fused deposition modeling, FDM, to 3D print flexible plastics directly onto existing fabrics. Kau's team developed flexible, smart textiles using 3D printing and special hybrid inks. These respond to electricity, light, pressure, think wearables, interactive surfaces.
Hybrid inks, what's in those?
Things like cellulose and embzene. And Peng's team even developed a unique 3D printer that prints layers of fabric to make 3D deformable objects.
Printing actual fabric layers, that's wild. But like nano, any environmental watchouts with 3D printing textiles?
Yeah, energy consumption. 3D printers can use a fair bit of power, so running them on renewable energy is definitely something to aim for.
Makes sense. We also talked about creating smart and functional textiles directly. How's that usually done?
Often by using materials that are inherently smart, like conductive fibers carrying signals or sensors detecting changes in the environment or on the body. These let textiles monitor temperature, moisture, adjust insulation, even generate tiny bits of power for movement.
What are some examples of these smart materials being developed?
Gauch's team combined conductive polymers and reduced graphene oxide with regular fibers like nylon or wool.
Graphene again.
Right. The result was conductive, shielded against EMI, good thermal properties, water repellent, stress resistant. Imagine fabric as a touch interface, protecting you from signals and being durable.
That's a lot in one fabric.
Totally. Wang's group used co-electrospinning to make fibers that adapt to changes in temperature or pressure, and Shahid and colleagues looked into new ways of spinning yarn from jute blends.
Sounds like endless possibilities. But again, any environmental red flags with these methods?
Absolutely. The chemicals used in production, if they're not handled or disposed of correctly, they can definitely harm the environment. So greener processes and thinking about the end-of-life stage are really crucial.
Okay. Now let's switch gears a bit to something really important. What happens to clothes after we're done with them? Recycling seems like a critical piece of the NGT puzzle.
It absolutely is. Recycling old clothes effectively is a huge opportunity to lessen the textile industry's environmental impact. With awareness growing about textile waste, sustainable recycling methods are becoming more and more important.
What are the main ways we recycle old clothes?
Several key techniques. First, there's mechanical recycling. That's physically breaking down the textiles into fibers, which can then be spun into new yarn, often used for natural fibers like cotton and wool.
Does it work well for everything?
It gets tricky with blended fabrics, where different fibers are mixed together.
Right. I've heard about open loop versus closed loop recycling, especially with wool. What's the difference?
Good question. Russell and colleagues explain this. Open loop is when old wool is processed into fibers for things other than clothes, like insulation or padding.
Okay.
Closed loop is the goal, processing the old wool back into new wool yarns good enough for making clothes again. It keeps the material in the high-value textile stream, but it needs careful processing to maintain quality. There's also potential to use these recycled fibers in advanced composites later on.
So what if the fibers are too damaged, or it's a tricky blend?
That's where chemical recycling comes in. It uses chemical processes to break down the textile structure into its basic molecular building blocks.
Ah, back to the raw ingredients.
Exactly. These molecules can then be used to make new fibers. It's often better for synthetics like polyester and nylon, and it can handle mixed fibers better. People are even looking at extracting valuable stuff like nanocellulose from textile waste this way.
And then there's taking old clothes and making something completely new and maybe even better, upcycling.
Precisely. Upcycling transforms waste into higher quality products, often uses less energy and fewer resources than making things from scratch or even traditional recycling. It fits really well with the circular economy idea.
Doesn't make a difference.
Singh and colleagues pointed out how upcycling businesses can create cool products, green jobs, and boost brand image. Telly showed how all sorts of textile waste can become ropes, scarves, bags. But even upcycling has some environmental footprint, depending on the process.
Right. And what about recycling, say, old jeans back into new jeans? Textile to textile.
Yes, that focuses on specific categories. Muthu described it for denim. Shred the old jeans, maybe blend the fibers with some new ones for strength, then spin and weave new denim fabric. It saves virgin resources and cuts down landfill waste.
So, lots of ways to give clothes a second life. What about growing textiles? That sounds really futuristic.
That's bioengineered textiles, producing materials from living organisms like bacteria, fungi, algae. Ramon and colleagues talked about this.
Seriously, growing fabric.
Yeah, and Shiros' team is even engineering proteins at the nanoscale to improve these biotextiles. But we need to be careful. Large-scale cultivation could have environmental risks, impact biodiversity, needs more research and careful management.
Okay, that's definitely out there. It really feels like using sustainable and recycled materials is a theme running through all these NGT developments.
It's fundamental. Using eco-friendly and recycled materials is key to shrinking the footprint. Lean and colleagues even found a way to recycle cotton polyester blends into glucose and new polyester.
That's clever.
Using recycled plastic bottles for polyester fibers, like Palisar and Hossain explored, is another great example. Sari's team looked at combining maize husk fibers with polyester for sustainable building materials.
Wow. Textiles and buildings.
Yeah. Yin's work on a wearable bioenergy microgrid points to self-powered sustainable tech. And Kai, using waste wool for insulation, shows the value in existing resources.
And we can't forget the smart part, embedding tech right into the fabric. Wearable technology integration.
This is where electronics become part of the clothing. Hamedi showed how coating fibers with conductive polymers creates basic circuits in the fabric.
So the wires are the fabric.
Essentially, yes. Liu, Khalid, and others have looked deeply into textile strain sensors, how they sense movement, pressure, crucial for monitoring applications. A big consideration here is minimizing the energy these wearables use.
What about making the fabrics themselves greener, like how they're dyed and printed?
Yes, big focus there too. Advanced dyeing and printing aim for sustainability, drastically cutting water use and waste. Pei explored eco-friendly polyester dyeing using silicone solvent.
Silicone solvent, okay.
Egerwall discussed waterless dyeing with supercritical carbon dioxide. And Libertino showed microdispensing for precise 3D printing, which also cuts waste in printing patterns.
And you can add finishes to boost performance too, right?
Exactly. Performance-enhancing finishes like water-repellent coatings improve function and can make textiles last longer. Wang's team made water-resistant polyester using Emzine, which also gave it EMI shielding and heating abilities.
Emzine.
Yeah.
Sounds familiar. Any drawbacks?
Yeah, the environmental impact of Emzine itself is a concern. So finding eco-friendly alternatives is really important for finishes like these.
It's amazing how many different fields are converging here, even AI and machine learning.
Absolutely. ML and AI are used to optimize production, cut energy use, improve quality control. Line's group developed meta surfaces for wireless communication with medical implants using AI, and an intelligent system for monitoring blood pressure and heart function with deep learning. Chen used deep learning for an automated system to braid electrical cords for user interfaces, interpreting gestures.
That's complex stuff. But more tech means more potential e-waste, right?
Good point. Increased e-waste and the carbon footprint of AI are definite considerations. Energy-efficient algorithms, responsible e-waste management, they're crucial.
And we're even looking to nature for ideas. Biomimicry.
Yes, imitating natural systems. Salahuddin coated cotton yarn with nanotitania for self-cleaning properties like a lotus leaf. Just need to be careful not to overexploit natural resources while we're being inspired by them.
Makes sense. We also touched on advanced spinning and intelligent fibers earlier.
Right. Leon Bois incorporated graphene into polymer fibers using dry jet wet spinning, boosting electrical and mechanical properties for wearables. And Mokhtari highlighted intelligent fibers combining low-power communication and tiny electronics right in the fiber.
So the fiber itself is smart.
Pretty much. And even the fabric structure, how it's woven or knit, is being redesigned.
How so?
Dong discussed how 3D fabric structures can better integrate tech, even improving energy harvesting from friction contact electrification.
Which brings us neatly to harvesting energy from our clothes, textile energy harvesting.
Yes, capturing and storing energy from around us, body heat, movement. El-Mouvni demonstrated thermoelectric generators woven into textiles to harvest body heat.
Does it generate much power?
It's promising, but increasing efficiency and overcoming technical hurdles are still major research areas. Needs to get better to be truly practical.
This is all incredibly forward-looking. So realistically, what's the future prospect for next-generation textiles?
The outlook is honestly exceptionally promising. We can expect huge leaps in performance and function.
Like what specifically?
Think better self-cleaning tech using things like TiO2 and ZNO, as Saad described. Fabrics that actively manage moisture to keep you comfortable, like Miao's work on directional water transport. Phase change materials and hospital sheets for temperature regulation. Shahid looked at that. Even wearable personal heating and cooling systems, like Tabor worked on. Chaudhry highlighted the massive opportunities and the challenges still remaining in wearable electronics built into textiles.
And sustainability will become even more central, presumably.
Absolutely. The drive for eco-friendly options, biodegradable, renewable materials, that's only going to grow stronger. Shahid emphasized this. We'll likely see more natural plant dyes being used, like Aurora researched.
Less chemical dyeing.
Hopefully. More focus on green practices across the board, as Arafat and Udin stressed, more use of recycled cotton, like Boulan and Gogoi studied, and just a better appreciation for natural fibers' own sustainable qualities, which Suparna and Rinzi wrote about.
And the line between clothes and tech will keep blurring. Smart textiles, wearables.
Definitely. More smart fabrics with conductive fibers acting as soft sensors, like Caponeri discussed. Clothes that sense body temperature using special yarns, Lugoda looked into that. And even more sophisticated garments, like Cho's cross-type clothing with textile electrodes for heart monitoring.
So more health monitoring built in. It also sounds like we'll get more, say, in our clothes, customization.
Yes. Production is evolving towards that. Sid Atta discussed blending additive manufacturing, like 3D printing, with traditional textiles for customization. And Saidam explored how CAD tech enables efficient mass customization.
Tailor-made tech clothes. And they'll probably get better at protecting us, too. Safety features.
For sure. Expect more NGTs designed for safety. Cut-resistant textiles using things like Kevlar, like Dilagavathi worked on. Fabrics with built-in flame retardants and antimicrobials, Nabipur looked at those, and just overall better performance from protective textiles, as Papa Spirides reviewed.
This all sounds amazing, but there must still be big hurdles, right? Challenges to making this mainstream.
Oh, absolutely. Several big ones. First, the cost. R&D for these advanced textiles isn't cheap. Church and Korger's work touches on the costs of new techniques. Open innovation sharing knowledge and resources could help here.
And going from lab bench to factory floor, scaling up.
Huge challenge. Scalability and cost-effective mass production are major roadblocks for many NGTs, as Libertino and Hossain noted. Again, open innovation might help bridge that gap.
And safety is paramount.
Yeah.
New materials, new tech. Gotta make sure it's safe. Regulations, too.
Totally crucial. Diane Jeon highlighted this. Rigorous testing for consumer and environmental safety throughout the life cycle, plus clear regulations, are essential for trust and adoption.
And will people actually want to wear this stuff? Consumer acceptance, awareness.
Key factor. Overcoming potential hesitation about tech and clothes and clearly explaining the benefits. That's vital for market success. Beggars-a-Day and Grankarich touched on this. Needs to be user-friendly with clear advantages.
Even if they're meant to be green, are there still environmental impacts to watch out for during production or disposal?
Yes. Even with sustainable goals, some processes or materials can still cause harm if not managed right, as Wang and Monferrat pointed out. Proper waste management and end-of-life plans for these advanced textiles are essential.
And durability. Will these high-tech fabrics last? People don't want clothes falling apart after a few washes?
Absolutely critical. Ensuring NGTs withstand wear, tear, cleaning, that's crucial to avoid waste and ensure value, something Mulatier, Sun, and Lin have researched.
Okay, so challenges remain. But despite them, the market seems ready to boom.
It really does. Strong growth predicted for intelligent textiles, AI, and fashion, energy harvesting clothes. The 3D textile printing market is expanding fast thanks Stratasys, Carl Mayer, as Lopez Camacho noted.
4D printing, too, where things change shape.
Yep. Huge potential there, according to Minaya. Nanotextiles are growing, with companies like Nanotex involved based on Inchikova's findings. Bioengineered textiles from firms like Modern Meadow, Bolt Threads are gaining ground, and just huge demand overall for intelligent textiles from brands like Adidas, AQ Smart Clothing, highlighted by Sayovich. The demand for NGTs across many industries is high and rising.
Wow. Okay.
So, to kind of wrap up our deep dive here, we've covered a lot of ground on next-generation textiles. What are the absolute key takeaways for you, the learner?
I'd say the main things are, 1, the sheer pace of exciting advancements, nanotech, 3D printing, sustainable materials, smart tech integration. 2, the incredible potential NGTs offer better performance, function, more sustainability, seamless connection with our digital world.
Right.
And 3, acknowledging the real challenges that still exist, cost, scaling up, safety, consumer acceptance, environmental impact, and making sure they last.
Exactly. And hopefully for you, the learner, this gives you that solid foundation, those aha moments about this fast-moving field without feeling totally swamped. So ultimately, what does this all point towards?
It really points towards the very fabric of our future being rewoven. Threads of innovation, threads of sustainability. These advancements could truly revolutionize not just what we wear, but how we live and interact with the world.
Okay, here's a final thought for you to mull over. Given those big environmental problems with traditional textiles, how might widespread adoption of NGTs really reshape our whole relationship with clothes and consumption? And what totally unexpected, maybe even wild possibilities might pop up when our clothes become genuinely intelligent and start interacting with everything around us?